we are going to look at some algebraic equations, and we are going to be solving them, but we're going to be providing justifications while we solve them. This is actually an introduction to our proofs that we do in geometry. Typically, the proofs that we do are going to be what's called two-column proofs, which is actually what you see here. The left-hand column are called statements. Those are going to be our mathematical statements. And then our right-hand side is our reasons. Reasons can be things like properties, definitions, theorems, and postulates. So we are going to practice this with solving algebra equations. You can see that we are given an equation. We want to prove that it equals x. Now that does not mean take 3 and plug it in. That means we're given a starting point. We need to then work with this equation to show and justify that x equals 3 is the answer. And we're going to justify using the properties of equality we just learned. There's one other little thing we need to talk about that we can use as a justification. It's not technically a property. Well, I guess it is a property, but I want to talk about it in terms of like algebra. You know how sometimes you have to maybe combine like terms or rewrite something? We typically call that simplifying, but there's no simplification property. So if you simplify on one side of an equation, we're going to use the substitution property to justify that. So if you combine like terms or reduce a fraction, something like that, we're going to call that the substitution property because technically what we're doing is substituting an equivalent value in. And we'll see that in a second. So first example, we are given that 3x plus 2 equals 17. We want to prove that x equals 3. Now, when we're doing our two-column proofs, there's actually some freebies. The first 2 blanks are freebies, and then this last statement here is a freebie. Our first statement is always whatever is given to us, our given. So we're going to put that in our first statement box. So we are given the equation 5x plus 2 equals 17. Now our reasons are justifications. Now, what's our reason that this was the equation we're dealing with? Because we were told to. That is what we were given. So our first statement, okay, is always our given. Why? What's our reason? Is simply that it was given to us. And then our last statement is always where we're trying to end up our proof. We're trying to show that x equals 3. Now then, since we put given in our first reason, it's very tempting to then go, oh, prove goes here. No, prove is never a reason. That's like saying because I said so, right? Or list, that's not a valid argument in mathematics. Sorry, no matter how much people love to use it, it just doesn't work in proofs. So this is not a valid reason. We don't actually know the reason yet. We're going to have to figure it out as we go. But these are our freebies. So now let's just think algebra. 5x minus 2 equals 17. What would you do to continue to solve this? Well, we're trying to solve for x, which means we need to do some opposite operations here. So the next thing that I would do is I would subtract 2 from both sides. And I would get 5x equals 15. So then my next reason is going to be what allowed me to go from step 1 to step 2. Why could I say that 5x plus 2 equals 17 would lead me to 5x equals 15? Well, we subtracted 2 from both sides. So our reason to get from step 1 to step 2 was the subtraction property. So our reason is what justified us from moving from one step to the next. Okay, think of these as like if-then statements. Okay. So if I know that 5x plus 2 equals 17, then I can conclude that 5x plus 5x equals 15 because of the subtraction property. Okay, you don't actually, when you're doing these normally, you don't have to write an if, then, and because of. I'm just kind of showing you the logic. So if I have this, then I know 5x equals 15 because the subtraction property let me do it. So now what's going to get me from step 2 to step 3? If I know that 5x equals 15, what property lets me then conclude that x just equals 3? Well, if I was just solving this algebra problem, I would then divide both sides by 5. So to get from step 2 to step 3, we would apply the division property. Okay. Again, if 5x equals 15, then we know x is going to equal 3 because the division property says so. Okay, so hopefully that helps you figure out your order a little bit. So one more. We are given that 3x equals 6 minus 1/2 x. Prove that x equals 12 over 7. So I'm going to start with my given. So my first statement is always going to be my given. 3x equals 6 minus 1/2 x. How do I know? Because I was told to solve that equation. Then my last statement is always my prove. It's where I'm trying to get to. I'm trying to prove x equals 12 over 7. Now, how am I going to do that? Now, this is one that there's more than one good way to do this. I'm just going to show you one strategy because there's normally multiple ways to solve equations. I personally like to, first thing, get all my x's on one side. So I'm going to move my 1/2 x over to the left by adding 1/2 x to both sides. So if I add 1/2 x to both sides, 3x plus 1/2 x is going to give me 3 and 1/2 x equals 6. And I did that. I was able to get from my first step to my second step by adding 1/2 x to both sides. So that is the addition property. Okay. So next thing, if I have 3 and 1/2 x equals 6, then what could I do next? Well, this is kind of up to you. I can see here that my final answer is written as a fraction, so I'm not going to waste my time turning this into a decimal. Instead, what I'm going to do is turn this into an improper fraction. So I know that 3 and 1/2 is equivalent to 7 over 2. I did that by taking 2 times 3, which is 6. 6 plus 1 is 7. So I know that if I have 3 and 1/2 x equals 6, then I can also say 7/2 x equals 6. Well, how did I do that? Well, I know that 3 1/2 is equivalent to 7/2. And if you look up at the top, we said that if you simplify on one side of an equation, use the substitution property. Well, that's what I did. I rewrote this, right? I simplified. I turned 3 and 1/2 into 7/2. So that is the substitution property. Right? I know 7/2 is equivalent to 3 1/2, so I substituted that in for it. Now what can I do? Well, again, algebra can be done in a couple different ways. So you could do this. We're actually going to do this. You could do this in one step if you wanted to. We could multiply both sides by the reciprocal, and then you would actually be done. From my experience, a lot of people don't remember multiplying by the reciprocal or get it wrong. So we're going to do this in 2 steps. We're first going to multiply both sides by 2 to get rid of this over 2 part. So if I multiply both sides by 2, that's going to give me 7x equals 12. How did I get that? I used the multiplication property. Okay. Now, how can I get from 7x equals 12 to x equals 12 over 7? Well, I would divide both sides by 7. So I can get from step 4 to step 5 using the division property. So if you're ever doing one of these proofs and you do your algebra a little differently, You might need a different number of steps than me. You can always add one. Normally you don't use too many less, but if you do something a little different, like multiplying by the reciprocal, then that would reduce this by one step. All right, so make sure you get this done for class on either Thursday or Friday, depending on what block you are. Then we'll do our content check and work on our assignment. Have a great day.